At AP review, we're doing 2017 ABBC for response 1. It's a table problem. Remember that in table problems, there's two really common problems. They don't always happen, but it's pretty safe bet that at least one of them, if not both, does. One is that you might be asked to estimate the derivative of this function by finding slope from two values on the table. And the other one is that you might be asked to estimate the integral of this function by using an area approximation method on this table, like LRAM or RRAM or MRAM or trapezoidal. So those are the two common things that you see on a table problem. It's not like there couldn't be other questions, but it's good to know that those are the two most common questions you see. So a tank has a height of 10 feet. The area of the horizontal cross-section of the tank at a given height, h feet, is given by the function a, where a of h is measured in square feet. The function a is continuous and decreases as h increases. Selected values for a of h are given in this table. Part A, use a left Riemann sum, hey look, area approximation, with 3 subintervals indicated by the data on the table to approximate the volume in the tank, indicate units of measure. So in part A, right, they want me to use a left Riemann sum, right? So that just means boxes, but use the left of the two y values as the height of your box. So this box has a width of 2, but a height of 50.3. This box has a width of 3 from 2 to 5, but a height of 14.4. Because again, I'm using the left y value, hence left Riemann sum. This box has a height of 5 and a width of 5 and a height of 6.5. So my volume is going to be approximately the 2 times the 50.3 plus the 3 times the 14.4 plus the 5 times the 6.5. Now, if I were you, I would write that out because that work is getting you some credit, right? And then it's a calculator section, so you're going to type that in your calculator, and when you do, you're going to get approximately 176.3, and that's in feet cubed, right? Cubic feet are feet cubed because we're talking about volume, and it was area, which is feet squared, times height, which is also feet, so feet squared times feet is feet cubed. Part B. Does the approximation in part A overestimate or underestimate the volume of the tank? Explain your reasoning. Okay, so underestimating and overestimating can be about a bunch of different things. But in the case of LRAM and RRAM, when we talk about under or overestimating, what I want you to notice is that because, so A of H is decreasing, right? So A of H is decreasing. They specifically went out of their way to say that as the tank gets taller, the cross-sectional area gets smaller. So the left Y value, right? So the left A value is always greater than the rest. Like it's always, so is the max, right, on any given interval, right? So like just to show you a visual of what I mean by that, here's an example of a function that's decreasing. If I draw boxes from the left endpoint on a window, see how that's always too high? So an LRAM approximation is an overestimate. So see how these, because it's a decreasing function, using the left y value is always higher, so an LRAM approximation is an overestimate. Okay, and basically they just needed you to point out that a is a decreasing function, and that makes an LRAM an overestimate. Cool. Part C. The area in square feet of the horizontal cross section at height h is modeled by the function given here. So let me erase some of this. And we might need the table again, so I won't erase it because I frequently end up regretting erasing things that I end up needing to recreate for you again. So we have f equals 50.3 divided by e to the 0.2h plus an h. Cool. So this is the area of the horizontal cross section. Based on this model, find the volume in the tank. So this is saying this is another model for what we already know, right? So this is another model for the area. And they ask us to use this model essentially to approximate the volume. From 0, it's 10 units tall is how tall the tank is. So using this estimate, the volume is approximately the integral from 0 to 10 of f of h dh, right? Now I'm going to make my calculator do this, right? There's no reason for me to do it, so I'm going to put this in as y1 in my calculator. Instead of using h's, I'm going to use x, right? And then, so if we go to my y1, right, I'm going to put in 50.3 divided by, in parentheses, an e to the 0.2h, which is going to be x, right, plus an x, which is my h, right? And then I'm going to go ahead, so I put that in there, right? I'm going to quit out, and I'm going to do a math 9, which is function integrate, of my y1, so vars over to y vars, pick function in y1, comma, with respect to x, from 0 to 10 and hit enter. And hopefully I get the right answer. It takes a sec. All right, yep. And so we get 101.325, and again, that's cubic feet, right? Make sure if there are units in the problem that you include the units, okay? So, part D. Oh, and they said based on this, find the volume, so it would actually be equal. Okay, so they didn't ask us to approximate. Part D, water is pumped into the tank. When the height of the water is 5 feet, the height is increasing at a rate, this is a related rates problem, of 0.26 feet per minute. Using the model from part C, find the rate at which the volume of the water is changing with respect to time when the height of the water is 5 feet. Okay, so we'll erase the whole thing. Cool. All right, so this is related rates, right? So we know that the volume of this thing, right, the volume at some height h, is the integral from 0 to h of f of, pick a letter that's not h and not t, because we're about to derive with respect to time, right? Cool. So I now want to find, so what I want, right, this is an equation for v, right? I want dv dt at the time when t is, at the time when the height is 5, right, at h is 5, and I'm given that when the water is being pumped into the tank, at the moment when h is 5, so at h equals 5, the height is increasing, so dh dt, at 0.26 feet per minute, right? So I know dh dt. So what I want to do is I want to derive this thing with respect to time, and that'll allow me to find an equation for dv dt. So when I derive with respect to time, right? So when I derive this guy, I'm going to get dv dt, right, equals, and then I'm going to derive this guy with respect to time. So derive with respect to time of this thing right here, right? When you derive an integral, they essentially cancel, right? But in order to cancel this, right, so I'm deriving with respect to t, right? So I get the dv dt, right, is f of h, right, times the derivative of h with respect to time, so dh dt, minus f of 0 times the derivative of 0 with respect to t, which again would just be 0. So I get the dv dt. So this is using that second fundamental theorem of calculus. dv dt equals f of h times dh dt. Well, I know some of this stuff, right? This is the thing I want, right? This is a thing that that I was given. This is a 0.26, right? And f of h is a thing I can find, right? Because so this is a 0.26 at h equals 5, and I can plug in to get f of 5, right? So what that means is if I go to find my value, my dv dt when h is 5 is going to be f of 5 times a 0.26, which is a thing I can type in my calculator, right? So when I type in f of 5 times 0.26, there's a couple different ways to do this, right? One way to do that is if you have in your y equals, this y1 is my f, right? If I hit trace, actually let me zoom 6 because I have a weird window. All right, so let's say I zoom 6. Gonna get my crazy window. If I hit trace, right, I want when h, which is my x in this problem, h is 5, so I hit trace and hit 5. That now makes my y 6.51699945. Great. But if I quit out of this and I hit alpha y, it's going to have stored that as the value I want. So I can take that value and times by 0.26, and there you have it. I get a 1.694491, blah, 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 blah. So I get that it is 1.694, and that's all I need. And because it is dV, which was cubic feet, over the time, which was minutes, there's my answer. Again, you don't have to know stuff on the shortcuts on the calculator necessarily, like tracing stuff and then having that y value stored, but it's a whole lot easier.